Hi folks, Mr. Long here. Today we're going to talk about function transformations with BEDMAS. And what we've got here is a handout with this chart. What we're going to do is each row on this chart represents a transformation of a function. Right? We start off with simple graphs like the graph of y equals x squared that passes through 0, 0, right? That's the simplest quadratic graph, or the graph of root x, which we know passes through 0, 0, and then looks like this, and so on. Okay, so we take simple graphs and we transform them by applying mathematical operations that relate to BEDMAS and specific functions. So, and in fact, we start all of these with a straight line that we transform into, for example, a quadratic or a square root function. So, what we're going to do is I'm going to work through row I and row J with you, and then you're going to work through the rest of them. Okay, this is really important stuff to get. It's a lot of work initially, step by step, but we'll make things more efficient a little bit later. But you have to do the step-by-step work so that you understand everything. Okay, it just requires some work. So what I want to show you is how this handout works. So that's the table, the data that we're going to work with, the equation we're going to work with, and then there's answers. So you're asked, for example, to figure out the transformations. And then when you get done part of your chart, as you'll see later, you come back here and you look. So for example, for vertical transformations, you're going to look and see it says, is it a reflection? Yes. Is it a stretch or compression? And for I, it should work out to a stretch. What stretches it? What is the factor of the stretch? Like how much does it stretch by? What factor? 5. It means that all the y values multiply by 5. Does it shift or translate? Yes, it does. It shifts up by 1. Horizontal transformations. Does it reflect? In this case, no. And then it looks as though there's no shift at all. No translation left and right. Okay, so those are how you get your answers. And then there's actually, if you go to the next page, you'll see that there are now answers for things like, for the quadratics. So we're going to again be working on row I for quadratics. It says the vertex should be at 0 and 1 when we get done. If I take a point 3 to the right, the coordinates of it should be 3, negative 44. And the range should be from negative infinity up as far as 1. Okay, the minimum is negative infinity, the maximum is 1. Now, we know that anytime infinity is involved, it's a round bracket, and if 1 can be included, it would be a square bracket, just as a reminder. Okay, folks, so again, you look at the table in the front, and then your answers follow, and then finally on the last page is an actual handout. Okay, and here's the handout. So let's go through this. So here's the first function we're going to work with. The very first function we're going to work with is negative 5f 1 over 1x plus 1. And this was, I believe it was row I. Row I in the table at the front. So again, we're going to follow BEDMAS. So if we look at this, the first thing that I want to do is use BEDMAS operations. Well, I've got this nice big square set of brackets, and what's inside the brackets? Well, it's 1x, 1 over 1 because it's rise over run. So what does the line, so if you look at this, what is this? It's the graph of the line, 1 over 1x. So it's 1x, it passes through the origin because it's 1x plus 0, right? And it has a slope of 1 over 1. So it passes through the origin, and my key point for parabolas is always 3 units to the right, and then it has to be 3 units up, okay, because it's a 1 over 1 slope. So I've got 2 key points. Okay, so let's record those. We've got a table below. So our first key point is at the origin. We always make a point at the x-intercept of the line. So that's going to be 0 and 0, and the other key point, 3 units to the right, will be 3 and 3 because it's a straight line with a slope of 1. Okay, so what happens after that, after we do the brackets? Well, the next thing moving out is, in fact, f, the function rule. So the function rule we're going to deal with this time is the squaring function. Okay, so I've got to take all of those y values and square them. Remember, I'm only working with y values. So there's the first table, and now I'm going to go to the function rule. So I'm on to the function rule. The function rule says for this one I'm going to square. I know my key x values are 0 and 3, but I have to take this 0 and I square it. 0 squared is 0. There's no change. That's called an invariant point, not varying. And then I have to square 3. And that is 3 times 3, which is 9. Okay, so those are now my two key ordered pairs after I've applied the rule F. Okay, what happens after this? Well, we need multiplication in bedmass, according to bedmass. So this part here, that was the bracket. And I know F, the rule F, doesn't appear in bedmass, but it is in fact related to it. We apply the function to the brackets. And then after we get done that, then that negative 5 sits out there. Negative 5 followed by F means negative 5 multiplied by F, right? So let's go back down and let's apply that multiplication of 5. We call that value the A value. Oh, whoops, it's negative 5, not 5. Okay, and I probably should make this so I can see it a little bit better. So again, the x values don't change. 0, 3, and I've got 0, which I have to multiply by negative 5, still 0, and I've got this 9 right here. This 9 multiplies by negative 5, and that gives me negative 45. So I can see that y value of 9 has shifted to a y value of negative 45. Why is that? Because I'm multiplying by 5, which expands the graph or the table, like the number, which is a stretch, and it's multiplying by a negative, so it's now pointing down 45 units from the origin rather than pointing up. Okay, so let's see here. And if I look at this as I go, what kind of transformations did I do? Clearly, there was a stretch here. So I should put an ST there as a stretch. And the factor is 5. I'm just writing this down. And then there's also, yes, there is a reflection because that value was negative. Okay, next. What comes next according to bedmass? Looks to me like it is plus 1. Now we're adding and subtracting to y values. So let's go down here. So we have a plus 1 for Q. Q is a plus 1. Okay, so I'm adding 1 to all the y values. 0, 3, the x key values don't change. I take that 0. I add 1 to get 1. I take this negative 45. I add 1 to get negative 44. Okay, and what I have here always, that first key point, will be vertex because that's at the 0 square. This second key point really just helps us understand the shape of the curve. And by the way, that's a vertical shift, and it's up 1. And we can check that with the answers that are provided. Okay, I need to make a final sketch. So what should my sketch look like? Well, I know the highest I go is 1, and the lowest I'm going is negative 44, right? So I'm looking at those y values. So I probably should set up my graph something like this with x and y. I know that an ordered pair is 0 and 1. Another ordered pair is 3, and then down negative 44. There's another ordered pair. Let me put those in red so you can see it a little bit better. So there's an ordered pair. The first one is at the vertex. So it goes like that. By symmetry, this one will go down like this as well. Now one thing we could do is you certainly don't have to, but your delta y will be, in this case, from 1 to negative 44 is negative 45, and delta x will be 3. Okay, delta x is 3. And I think if you did negative 45 divided by 3, you'd get negative 9. Right, so and that shows you, that, sorry, yes, that's 9. 3 squared is 9. Anyway, that's besides the point. Sorry, folks. I digress. Okay, let's go and summarize all our transformations. Okay, so what is the domain? Well, for any parabola, it's always just negative infinity to positive infinity. I can square any number, and it approaches. It doesn't actually reach infinity, so I put round brackets. The lowest this graph goes, the least value, is it's pointing to negative infinity. It approaches that, so that's a round bracket. But it can get as high as 1, and it can actually touch 1, so that's a square bracket. Then what we do is we describe the transformations once we've done domain and range. Well, what transformations do I have here? I've got a horizontal translation, and let's see, do I have any horizontal translations rather? It didn't move side to side, and so there is no translation left and right. And there's no reflection. Oh yes, horizontally? No, there's no horizontal reflection. So we've got a 0 there. It didn't move. Is there a vertical reflection? Yes, we multiplied by -5. Did it stretch or compress? Well, it stretched by a factor of 5. Did it move up or down? Yes, it did. It moved up by 1. Okay, so, and again, you can check all of those values are in the answer tables, okay, in the answer keys, so you can check and see if you're right. And I realize this is a lengthy screencast. I'm just going to get started on the next one, which we'll use as a square root graph. And I might even go through this one reasonably quickly. So let's see here. Again, brackets. So I'm going to do, f is going to be the square root. So I start with my bracket. So what's in my bracket? This right here. The straight line -1/1 bracket x plus 1. Well, how do I get the x-intercepts of -1/1 x plus 1? Remember, this is slope x-intercept form. So the only way to make x plus 1 in brackets 0 is if x is -1. And I also know that the slope of that straight line is -1, so it's sloping down. So it's going to look like that. Okay, that's what our straight line will look like. And that will be important later on. Okay, key points. This is a square root graph. So we always pick the x-intercept. And then we pick 4 units away. Now, we have to go 4 units to the left because we know that the red part I'm showing here is the only part that I can actually get the square root function, because I can't take square roots of negatives. So 4 units to the left of -1 will be -5. And what will that value be right there? Well, it's a slope of 1/1. If I go 4 units this way, I have to go 4 units that way. So that's 4. So let's write down our key ordered pairs. Okay, our key ordered pairs will then be, the first ordered pair is going to be the x-intercept, which is -1 and 0. And the second key ordered pair is 4 units to the left, which is -5, and 4 units up. So we're always going to pick 4 units up on that straight line. The reason for that is we know our nice square roots include 4. Okay, so let's now apply the rule F. That's what's next. Apply the rule F. And in our case, the rule F is square root, and that applies to the y values. -1, -5 will not change. Square root of 0 there is 0. Square root of 4 is 2. What's the next thing I do? Well, if I look, after I apply rule F, I need to multiply. What am I multiplying in this case? 1/2. Okay, so I'm multiplying by 1/2 the y values. So this is our a value is 1/2. Okay, -1, -5 don't change. 0 multiplied by 1/2 is still 0. 2 multiplied by 1/2 is 1/2. Oh boy. How about 2 multiplied by 1/2 is 1, not 1/2. Okay, and then the last thing I'm going to have to do is the add and subtract of bed mass. Okay, the add and subtract of BEDMAS, which in this case is minus 5. So I'm dropping all the y values down by 5. So that's negative 1, that's negative 5. This 0 drops by negative 5, so it's at negative 5. This 1 drops by negative 5. 1 minus 5 is negative 4. Okay, and now I have my 2 key points. Okay, and once I do that, I'm going to make a sketch. And again, it looks like to me like I've got my whole graph below the y-axis. So let's see. So again, it's just a rough sketch, right? So the first ordered pair, that will always be the cusp. So negative 1, negative 5. That's our first ordered pair. And that's going to be the cusp. Then the other ordered pair is negative 5 and negative 4. It's going to be right here. Okay, so my graph looks like that, right? The graph looks like that sideways check mark, if you will. Okay, and if you notice, it's opening to the left. It's opening to the left. Okay, so what is the domain? What is the domain? Well, the lowest x value is, if you look out here, the lowest x value is, it's pointing out to infinity. So it's going to go from negative infinity, and the furthest to the right it goes is negative 1. Can't touch, can touch. So the y value, what about the range? The lowest y value you see on that graph that's allowed is negative 5. The highest y value, it's pointing up, so it's going to positive infinity. Approaches but does not equal, can equal, square bracket. Okay, here let's look at the horizontal translations. Now normally a square root graph would open to the right, but since our line had a negative slope, this one opens to the left. So these are the horizontal reflections, or horizontal translations, so it did reflect horizontally. We also know that the cusp moved 1 unit to the left, so that is a shift left by 1. And finally, vertical translations. Vertically, there was no reflection, so I'll just put an X there. Was there a stretch or compression? Well, we multiplied by 1/2. So it's a compression, a factor 1/2. Did it move up or down? Yes, it did. It moved down by 5. And I'll just show you, it's the last little bit here. Normally, the square root graph, when it goes over by 4, would go up by 2, right? But if you notice, when this one goes over by 4, to the left by 4 in this case, it only goes up by 1. The square root of 4 is 2, but since we have an a value of 1/2, we only go up by 1. Okay, so it's less steep. That's a compression, a vertical compression. Okay, folks, so get to work. Start with A, and you might want to alternate parabola, square root, parabola, square root. You just need to do a bunch of these to get good at it, folks. It just takes work. Good luck.